We have a lot of material to cover today. One of the things I want to mention, and I'll put an announcement up, we will not have live class on Thursday. So I get to go to an advanced Excel training that day, so I'm going to learn about macros and all kinds of fun things in Excel. So both Miss Perriott and myself are going to be gone at that training, so we will get out at about 5:30. So even if you send emails, we'll probably not be able to respond to them during Thursday during the day. Even better, I have play tickets that evening, so I've got a very tiny window, so ask questions early. So this week we're going to talk about a lot of different things. We're going to look at chapter 6. We're going to start looking at something like functions. So in other words, those built-in things that are already existing, we're going to learn how to build them. So the print function that we use, we don't have to do anything other than tell the computer to print. Well, behind the scenes, there's a whole lot of coding in there. So there's a built-in function for that. That random code, there's a whole bunch of things behind that. Even the for loops and other things, there's logic behind those that we don't see. We're just passing everything into a function. And just like math, we pass those into that function with those parentheses, and it's kind of a black box. We send data in and we get something back out in a lot of cases. In some cases, we don't even get anything back out. It's just something happens in the background. Well, we use that all the time. So even in Excel, if I mentioned we're going to an Excel training. Well, one of the things you use in Excel, all of those things in functions are really the same thing. So if I launch Excel, so a blank workbook in Excel, the same thing we're doing in Python we do here. So if I want to do a formula, it starts with an equals. And so I have functions like now. And notice the same nomenclature. I'm passing in something into these brackets. Now equals now literally returns the current date and time. But any of the other functions I'm going to do, equals, and there's if functions. There's all these different types of logical things. So the same constructs we use, the same logic applies back into something like Excel. So last week, one of the tasks you had was to construct a program that would create a list of random variables, output that list, and it would output that in a random order, not repeating. And so there's a variety of different methods to do that. One of the most straightforward, if you looked ahead, and it's not necessarily in our book in this particular fashion, so we did encourage you to look around, is there is something called random shuffle. So in that random library, in that random function, so into the function random, so here we imported the library random, and here we're using the function random, we can do something called shuffle. And that reorganizes that list. In this case, they called it my list. And that works pretty well. Now, there's one problem with this program, and let me show you what happens. And I grabbed this kind of out of some of the students' homework, so we want to look at something. So it creates an index here. We can have several choices. So one of the things we can do, so we want to show random words. And I like this one because what they picked is just a set of numbers. And it's very easy to say, hey, those are in random order. So 9, 4, 3. Well, I'm going to escape out of here and run it again. Yes. And I run it again, get back into the screen where I'm recording. And you'll see there's a little bit of, and I'll show you what part of that is. So notice they are different in order. Great. So I can push the enter key just to exit, or I can add a word. So I'm going to add a word extra. So, choice 2, sorry. Add a word. So what word would you like to add? Extra. So now it creates a list of words. So I'm going to add another word. So add a word. Now, notice there's one little issue here when I run this. So because of our order, notice how it says press the enter key to exit, but if I put anything else in, then I go back to my menu. And so we might be able to make that a little cleaner in terms of that structure. But I also have one other issue with the way this is logically set up, and we'll look at it very quickly. So I'm going to show those random words. Notice this list of words, very clean. Those are random, the same random list we got here. So it's not re-randomizing this list, and look where our extra words end up. I can add multiples of those on the end, but I still end up with them just listed at the end. So let's look at the code really quickly, and we'll see why that's happening. Yes, I want to kill it. So it has the random shuffle up here in the very beginning of the program. So the program sequence is down here, and then it begins the program itself. So one option might be to re-randomize. So if the choice is 0, we exit. If it's 1, we print that list of random words, and we may want to re-randomize that list because we may have added extra words into that. And so we could certainly modify that so it would work in that particular. So here's how they added words. So in this particular case, they took a very straightforward. They said they input what would you like to add. And to the my list, which is a list, which is a little confusing, they use the append. So append word, so this value here is passed into the function append, and it then prints out an entire list of words, including your added word. So again, we might want to add that random function to show that we randomized it there again. Here we're allowed to remove a word from the list. So we take a word in, so similar type of structure, and then we created an if structure. So if word in my list, then we have the ability to remove it. Otherwise, we print out that's not in our list. So the other interesting piece that they did here was they validated their choice. And they said if choice greater than or equal to 4, print that's not a valid option. But the other thing they did, and notice we had that, it came up with that input at the end of our program. Watch what happens if I make this simple change. Okay. So now we're going to run. We resaved. So I'm just going to go through really quickly. So we show a random word. We add a word. And notice just by that simple little indent, so that indent was back in this line of the entire loop, and that's why it was asking for that input. And so simple little things like that. Run your code, check it, and go, oh, yeah. And it's those simple little things that sometimes will hang you up. So in this particular case, there's nothing truly wrong with this. It's just a little structure issue. And it's a good example of some of the things we can do. Now, this validate choice, let's try that and do something. So run module. So it says enter a choice of 4. So 4 or equal should say that's not a valid choice. Now, notice what it does. So I put in a choice that also isn't a valid choice, and it comes back up, but it doesn't print out that that's not a valid option. So let's look at that. So in this particular case, while choice is not equal to 0, so that's the only way to break out of that loop. So it still loops even though we don't get a validate choice. So one option might be down here is to, instead of greater than or equal to 4, since we know we have these 4 choices, so we could say if choice equal to and we could set up a list of those 4 conditions we want, and if it's not, then else. So in other words, we don't do anything on the if side. So if choice equals 1 or I put the 0 in the back. It doesn't really make any difference. So we would then put this in the else clause. So there's nothing really in the if clause because nothing actually happens. But you could put a statement in, thank you for your input, whatever. But that's one option to do it. There's other ways you could have done if it was between variables or values. And that way anything that's not, so if they put in a text input, they put in a number value, anything that's not those four choices explicitly defined, then it would print, hey, that's not a valid option, and you could put in, snarky comments like, hey, you moron, something else. So this is just one example. So make sure you look in. Make sure I haven't timed out a Blackboard here. So as I go through the grade book, and that particular problem came from Amber, and she did a really good job. So when we go into our discussion boards this week, so this week and last week, we ask you to post your code. And I think that's really interesting because you can look and see what other people have come up with, and already some people have posted for this week. So make sure you go in and look at it, try their programs, see what kind of things you get. There should be a list, and in other words, there should be 15 different ways to do this one simple problem. So this week, we start in on chapter 6. So chapter 6 introduces to a functions. So those same things, so those functions that we've worked with. So again, we used all different kinds of functions. We're going to create our own functions this week and learn how to do that. So we're going to take values into those functions, in other words, through a parameter, and we'll show you what that is. We're going to learn how to return information and what a global variable versus a local variable is. And so one of the things we're going to make is we're going to create a tic-tac-toe game. And we all know how tic-tac-toe works, so I just clicked on it and ran it. So here's the values for those positions. Now notice we start counting at 0 to make it a little easier to prepare with the computer. Do you require the first move? Well, nah, why not? We'll let the computer have the first move. And then your bravery will be your undoing. I will go first. I shall take square number 4. And of course, in terms of logic, that's always the place you want to go. We're going to take 0. And then you'll notice there that then we have to go to 0, 1, 2, 3, 4, 5, 6, 7. We lost. So it's a tic-tac-toe game. How it functions is a little different. So before we didn't have these idea of global versus local constants, functions. So we're going to define some of our own functions. So on page 159, we start talking about the idea that there's a lot of functions. So we've done length, we've done range, we've done the print functions. Well, we're going to create a function for instructions. And so that's the first thing they do here. And notice they use something called define, or DEF. And so that is this entire function, display instructions. So it's all these print statements. And so when I actually run the program, notice when I scroll way down, there's all those functions that get defined. Every piece of this program is functions. The only thing that actually is the program, notice here, we run one function called main. The entire program could be tucked offside in a file if we wanted to, and the only bit of the program that we actually are going to run is this piece here. The entire function runs when we call the function main. Now that's a little more dramatic, and they've done it that way to show you that, but everything in this program is built into functions. So even though all these things are in there, so there's a lot of coding in this one, the actual program itself is 2 lines. We call the function main, and we have our input line to keep the program open when we run it. So how do we define those functions? What is the advantage to that function? Well, I define those functions, and instead of having to have code repeat in my program itself, I can then recall those functions over and over and over again. And if I build the function correctly, I can pass different variables and different things into it. So on page 161, we look at how do we do a function? And literally, so I'm going to go down below here just so in some white space. Literally, we start our function by using the define. So we define something. And notice it lights up in orange to show us that we're doing something correct, hopefully. So it gives us our color coding. So we can call it anything we want to, within reason. And notice then I put my parentheses and a colon. And that is, we're now defining the function. So if I do nothing else but print I've created a function that can run. And so I'm going to do something interesting here. I'm going to copy and I'm going to start a new one. New file. And so I'm going to paste my function in there. So that is a function. And I always want to document these pretty well because it makes it easier to see what's going on. So sample function. So, and I may have 100 of these different functions of different types. So we define our function. All my main program is going to do, so I'm going to call that function. Notice when I do that, in this particular case, I'm not passing anything into that function. So I am just calling the function. So again, similar to here where I'm just calling that function under main. So let's see what happens if we were to run that program. Now, hold on, let me grab one more piece just so it holds. Just out of good practice, we always have this at the end of our program code. Because that way, if we invoke the program directly, run module, yes, and we're going to call it sample. Okay, so notice we've got some kind of syntax issue. So why would we have a syntax issue? So I defined my function, and then I tried to call my function. So let's take a look at what we've got going on here. So these functions work. So what's different between what I have here and what we've got going on up here? Do you notice any difference? So let me see if it makes it easier if I do this. So now you can see that a little easier than trying to squint up there because I know it's a little tiny up on the projector. So what is it that doesn't like about that? There's no colon, okay? So in this one, do I have a colon? I do, and I define the main. Is it an issue with the name? Well, let's just do this. So one of the things we encourage you to do is look at it and see, okay, is there an issue with, come here. So we could change the name. And there are some reserved names that can cause us some issues. So when I run it, we have to save it. So there must be something we need to look at. So let's dive into our book really quickly And let's look and see what we need to do. So we define a function on page 161. Of course, it talks about documenting your function. So you see the small difference I made there? One of the things that I found in a lot of programs are very simple typos. And this is one I found in more than one piece of code. So notice the difference. So we flip those around. We have to have the quote, and then, so much like any kind of parenthesis, we have to make sure that we have them in the correct order. And it's very easy to flip those around, and when our eyes look at it, you go, oh, there's an issue. So now let's run it. It'll make us save, yes. And now, notice that it works. So make sure when you define these and when you write your statements, you get things like this function, parenthesis in the right order. And that was very, very common this week. So double check, triple check your work here. So we defined a function that easily. We could define a second function. So we could define anything we wanted to. So we could define a function named Dan. And this function, maybe this function does print and so we could have a long function. We could do all kinds of things. But notice here what I can do. I can also call a function from within a function. And so if I run this one, nope, actually I got to do something first here. So rather than call Brad originally, I could call Dan. And notice it says, I am Dan, and then it says hello. So it ran both functions because we can call a function from within a function. And so our tic-tac-toe program does that. And so in fact, all we run to begin with on this program is we run the function main. So main, when I come up here and I look at it, main comes up and it says display instructions. And those instructions are way up here at the top, a function that we define. And so it makes it a little cleaner because we don't have all that extraneous coding in there. We just say, hey, I'm going to print the instructions. Get back down here. I'm going to assign things. And so here then it says we're going to assign pieces. Board is equal to new board. So here we run a function called display board, and that gives us our board. Even then in our while loop then, notice we're calling functions here. While not the winner board function, board move is a function. So all of these things we built in as functions. So it makes it a little cleaner. So this one they went the extra step, and just to show you that we could run that main from here, we could have done the same thing and left this piece just open and run all these in functions. Now, could we have ran the entire program by repeating those pieces of code over and over again? Sure. But a while loop that's this long is a lot easier to deal with than a while loop that's hundreds and hundreds of lines long full of code. So part of this is to make life easier for us. So one of the concepts we think about then is that idea of abstraction. So in other words, we assign something, so we worry about big picture items, display board, we look at while you're not a winner function, rather than all the minutia details. So we define all those individual pieces, and then we can define our overall program a little easier. So this idea of abstraction becomes pretty interesting. So we need to deal with in our functions. So this function is interesting, and I love how now we can call functions from within a function. So if I wanted this to repeat 100 times, I could do that very, very simply. I could just create a loop and call that function 100 times if I really wanted to. But sometimes we need to get data back out. So if I wrote a function, and so I'm going to come back here, and I want a function. So again, I'm going to start with define. And I can print things out pretty easily, but I want a function that will return a value. So I want a function that says, we don't want to use input because input's one of those keywords and we use it fairly often. So I'm going to call it Brad says, well, for whatever reason. So I'm going to create a function. All right. Now, in that function then, I'm going to ask a question. So let's call it response, just to make life easier. And I'm going to assign it the value of input. And again, I guess if I didn't put the negative sign, it'd be good. So input, and we can then, what am I doing here? Input. So I'm going to input my prompt. So please enter a word. And we're going to assign then a value of some sort. So we can do that. So we're prompting for some kind of value. So our input statements, we want to be able to figure out how do we get that value back out of this function. So we have a value internally. How do we pass that variable back out? So we have something we're going to call passing by parameters. So on the bottom of page 163, we start talking about the idea of passing through parameters. I'm going to open just for, backwards. A program here called receive and return. And so rather than have to type all kinds of things in, because my typing skills are bad, we have a couple of functions in here. So we have display message, so we print a message, whatever value is in message. We have a function here called give me 5, where we pass the value 5 into a variable called 5. And notice how now we end that function with this thing called a return. Okay. Here we have a function called ask yes, no. So we're asking a question. So let's see what this does, and then we'll look through the code again. So run it. So here's a message for you. So here's what I got from give me 5. So somehow it passed that back to 5. Enter a yes or a no, so I'm going to hit yes. Thanks for entering yes. Now, none of this is hard. We did this before, but the difference is, notice our main function is just display. Here's a message for you. Now, display says we're going to come up here and we're going to display the message. And so it passed these items here. So anything inside that parenthesis, it passed up into this function called display message. And so we defined display message. So this became the message that then it printed. The same way here, number equals give me 5. So we ran this function give me 5. 5 equals 5. So we have a value in that variable, and it returned a value back. So here it says number equals the value that's returned by give me 5, and we printed that number out. Well, now we can ask questions. So yes or no question, we get a response, and it returns that response. So that key phrase return allows our to feed a message back out of each function. And we're not limited to one variable, and we'll show you that here in just a second. We can pass several things back and forth. So maybe I ask yes or no questions often in a program. I don't have to rewrite that entire code every time. I can just call that function input. So think of our menu programs we've been creating where you have menus 0 through 1 through 4 or something. Now you could create a menu that we call a function get a value. It's got error checking. It's got all these pieces in it, and I don't have to repeat it multiple times. So on page 164, it talks about returning values, and that's what we just looked at. How do I return the values? So in this particular case, we also have to look at something about variables. So we have global variables that are available everywhere, and we have variables that are available only inside of a program. So we created this variable give me 5 inside of a function. It's only available inside of that function. And so if I take this out, so I'm going to take out the return 5, so I get rid of that. Because why can't we just say print a number? So number equals the value of give me 5. Well, why do I even need that? I could run that function, sure. Why don't I just print the value? We assigned it to 5, so let's see what happens. I'm going to run this, and it's going to give me an error because that 5 is not defined. Even though we ran it in this function here, it's defined only inside of this function. We have to pass that value back out in order to utilize it. So make sure you've read through how we can do this. So functions give us that ability to reuse things. So if we come up with a really clever way to do something, so here we're asking for a yes or no question. It's something we use a lot in our programs. Or an input statement, and that input statement values and evaluates data. We can reuse those over and over and over again. So we can use these user-defined functions. But we have to be able to pass information in and out of them. So we have the ability to do something a little better even than that. So here we passed in, close that. We're passing one variable back and forth. Well, we can do something even more interesting. So not just one variable, but notice in this particular example, we have a function called birthday. And in birthday, we have two variables, name and age. And name and age, wow, we have two different ones we can use. So here, let's run this and see what happens. So in this particular case, happy birthday, Jackson, I hear you're 1. Happy birthday 1, I hear you're Jackson today. In other words, we flipped them around to show you what's going to happen. Well, so birthday, so we call that function named birthday, and it passes in the values Jackson and passes in the value of 1. And it doesn't discriminate. So we have to make sure it's positionally related. In other words, we pass in value 1, pass in value 2, we pass in value 1, we pass in value 2. And so that's what it's trying to show you here, that that's what we're passing in. Now, in this particular case, So we can also pass it in this way. So name equals Jackson, age equals 1. But it does exactly the same thing. So age equals 1, name equals Jackson. Notice what happened when we ran it. So our first 4 lines, so if we set those up side by side so we can look at them and see what happened. So birthday Jackson 1, happy birthday Jackson, I hear you're 1. Okay. This one, because we flipped them around, says happy birthday 1, I hear you're Jackson today. Well, okay, so we had a little issue. This one then, because we assign it that name, so name and age, so happy birthday name equals Jackson, age equals 1. So our third example, that works. And notice here, birthday age equals 1, name equals Jackson. Because we assign him those variables, notice that it works in either direction. So it's just one other way we can pass values in. So you can, and we'll get to where we create a global variable that you can use in either place. If we define the variable in our main function, so from now on, most of our programs, we're going to have one big main function, just out of convention. And if we define the value there, it's available within the functions called from there. So we can do that. Now, there's some reasons why we don't always want to do that, but we can do that. In this particular case, this second one, so notice we have birthday 2, so we call that 5 times. So 1, 2, 3, 4, 5. Notice here we call birthday 2, and birthday 2 defines with a name internally, Jackson and age 1, print happy birthday, and so it passes it through the first time. It just says happy birthday Jackson. The second time we pass in name Catherine, and so it changes just the name variable. The second time we pass in just a single variable, and it changes the age. Then we pass in Catherine and age, and it changes both of them. And then we pass it in just by parameters. So it's just a multitude of different ways we can pass in variables. They do, and that's what we're doing here. So this first time, it's passing in the value of Jackson and age 1. The second time, that still exists because we didn't zero it out. So it would still have the value of Jackson in there until we override it here where we pass in the value of Catherine. It would keep Catherine because we've assigned. It was the last, whichever assigns it that last time. So we're just looking at how we can do that. So we actually look at variables on page 171. They start talking about it, and they use the value of something called scope. And so scope literally means how widely are used and available are the variables. Good programming tells us we don't use global variables very often. And the reason for that is we define all these functions and we define all these pieces, and we may reuse them in another piece of code. If we define global variables, sometimes we end up with variables in the wild, or we end up with variables that we can access from areas we don't want to access. So think of a very, very large program, not just our happy birthday program, but think of like an accounting program. And so I've set a value for wages of something for your CEO, and I don't want that available in other modules. I only want it available in the module that sets the salaries for executives, for example. So a lot of times we define those. there are some times when global variables are necessary and very, very useful. And so there are global variables. And so there's a program actually in your sample code. And I know we're going through a lot of material really quickly. Hit right click. So this one's called global variables. And what it defines is a global variable. And so here, so value equals 10. In the global scope, value has been set to 10. And here, because we assigned it in that main function, notice we can actually change and reassign it inside of our various modules. So let's run that and I'll show you what I mean. So in the global, value is 10. Back in the global, value is still 10. And so we're changing it internally, and it just shows you how we can change that. So let's look at our code here. So we assign value to equal 10. We printed it here just to show that we can. And those print statements, a lot of times I'll encourage you to put as many print statements in as you need to kind of understand what's going on. Here we're calling a function called read global. And so if I go up and see what it does, it just prints the function value. And notice it read 10. So over here it printed 10. So the next one then, we have one called shadow global. So back in the global scope, value is still blank. And so in here, it does something interesting. So we define our function, and it assigns value equals 10. And so we say, well, all right, so that's going to change value, isn't it? And so it prints from inside the local scope, value is blank. So in this particular case, from inside the local scope of shadow global, value is negative 10. Back in the global scope, because notice it calls this value here, it prints that, and then it prints a global value. And notice they're different. So in here, in this shadow global, it only changes it internally to that function. It doesn't pass that value back into it. So you almost might want to think about it as two variables at that point, because you have a value that's available internal to the program or that function, and a value that's external. And so we didn't actually change anything. What we have to do is we have to define that value as global inside that function before we can change it outside of the function. So we can keep them separate that way. So here when we define it as a global value, then it changes internally and externally. And so sometimes that'll be a little confusing if you try to look at that and you go, why is this program not working? Well, because you wanted to use a global variable and you didn't define it as such, it runs through my entire math function, or it runs through my entire function inside that piece, doesn't actually change it externally, and so we have an issue with that. So global variables are kind of a special case. Now, we use them inside of our tic-tac-toe game, but if you can get by without defining them, quite frankly, the best programming practice is we isolate those values to each function. Again, it's not a case of our tiny in scope, you know, tic-tac-toe games or something like that. It's not going to be an issue. Bigger values, bigger variables, and where it does become a little more of an issue is if we use, say, like an input statement, and we have a very generic input name. We use it as a local variable, and we just said, well, you know, let's make that a global, and we reuse it somewhere else, and we don't call that function. We may pass from one piece of a program to another a value we don't want. And so it's easy to do that. So on the bottom of page 177 is a list of codes and functions that we're going to use in this tic-tac-toe. So we create all these codes for these functions. So our main says, well, we know we're going to display the game instructions. We're going to display it, and we just call that function. We have a function called ask yes or no. We have one that's called ask number, and that ask number gets a number within a range. So we have pieces. So this just asks who goes first. We have one called new board, which gives us our new empty return board. Display board, and notice we're passing something into that board. So any function where we've got a variable inside those parentheses, we're passing in a variable. So legal moves. So receives a board, creates a list of legal moves. We have a winner board, so it determines the game winner, determines a piece, tells us if we have a tie. We have a human move, so where we input the move from us. Computer move, where it calculates the computer's move. Next turn is where it gives us a piece based on the current turn. And then we have a function for congratulate the winner. So in there, we're going to look at some of these functions then and see what they look like. So I still should have that open. Yes, I want to kill it. Yes, I want to kill that. So go back into my idle environment. Birthday wishes, return to C, tic-tac-toe game. Okay. So we want to look at some of these functions and see how we could construct them. And again, our games are getting more and more complicated, with the exception of we now know how to create these functions, so we can create a couple of things that are kind of handy. So notice up here, I talked about global, and we took that local variable. So notice here we define these as constants. Now again, Python doesn't have true constants like some other languages, so we can define them, user define them. We use a capital letters to define those variables. And so here we've defined x is equal to x, o is equal to o, empty is equal to a blank space, tie equals tie, and number of squares equals 9. So we just set those up as a default. So those are the game pieces. So x's and o's are our game pieces. Empties are what we put in the spaces that haven't been used yet. So we're going to display instructions. Well, this is pretty straightforward. So display instructions. Okay. So we have our triple quotes. We have a print statement. So if all I did was run this piece, we get our instructions. So if I run this, oh, I changed something. Oops, sorry. Delete. Okay. So if I run that, all right. So we get, notice I had some other crud in there, but we get prepare yourself human, blah, 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 do you require the first move? So our instructions, move that over as far as I can, move this over. So our instructions are this piece here. Print, welcome to our code. Notice what happens with that triple quote. Does that get displayed? Everything in our print statement gets displayed, but not that in those triple quotes up front. Are they inside of a print statement? No. So we don't document this with a bunch of documentation. What we're documenting it with is our triple quotes display game piece. So that just gives us an easy way to self-document. This is our piece called display the game instructions. So we're going to create a function that asks a question. So yes or no question. So we create a function for that. So we define ask yes, no question. Notice we have to use those underscores. They have to be one word for our function name. We can't have ask space yes space no. So the first thing we do is we're going to blank out response. So response equals none. So we have a variable named none. And then we ask a question. So while response, not in yes or no. So in other words, as long as we don't already have a value for yes or no, we ask that question, input question. Now, here we use the dot lower. And that's simply so if I put a capital Y, it returns a lower value Y. So we don't have to ask and or questions later on. It just brings out just those yes or no answers in lowercase to make life easier for us. And then notice this one says we're returning response. So response gets passed back up out of this function. We do the same thing here. We define ask number. So here we actually have three variables inside of there, and we return a response. So we return a single value back out. So we define this range. So we pass in that range of low and high. So we could change that. Those values get passed in of what that question is going to ask. So while response is not in the range of low or high, so we could change that dynamically. So we pass in two variables and get one back. Here we have a function for pieces. So we ask, go first, ask yes or no. So here we call that function, ask yes or no. So we pass in this value. So we are calling a function from within a function. So we ask yes or no, do you require the first move? So that comes back up and asks this question here, ask yes or no. If go first is equal to yes, then take the first move, and it sets up the human as X and the computer as O. If we say no, we don't require that first move, then it sets up the computer as X and the human as 0. And it returns both of those functions. So all that does is flip-flop whether we have X's or we have O's. New board. So new board calls a function called board. We have a function called display board. And so board then grabs all those values that are in there. So the first time that runs, those are all going to be blank. And as we assign those values when we call display board, those values change. So this is nothing more than a list of 0 through 8, so those squares, and we change it as we go through the program. Legal moves then just says which ones are available to move into, so we can assign an X or a Y to it. Ways to win. So this simply sets up all the conditions, the different possible ways in our tic-tac-toe to be able to win. And there's a limited number of those choices. So we can have all horizontal, all vertical, or 2 diagonals. So there should be 8 different ways to win. And if I count those, 1, 2, 3, 4, 5, 6, 7, 8, that is true. And so it checks if all those conditions are true. And so if it does, it says, oh, well, we're going to return winner. If it does not, it returns a tie. So human move is just the piece where we ask. So first we set legal, so we go back to the legal functions. We say, do we have a legal move? And while move is not in legal, we ask the number where they want to go. If it says it's not already occupied, it'll come back with a snarky response. Choose another number. So we're just asking if it's in any of those positions. And then we have a computer move. And what we've done with the computer move, there's no real logic to it other than we look at that squares and we know that these are the best moves to make. So we know that where's the best place to always begin if you're playing tic-tac-toe. And that's in the center. Well, notice if your computer starts, it's always going to pick that center. It's never going to randomly pick anything else. In which case, then we've just predefined these particular moves in that order. So it's always going to go 4, 0, 2, 6, 8, 1, 3, 5, 7. It's going to check if those are taken, and it does do a little logic here. It's going to ask if I can win. So it does have a little error checking here for winning and for blocking. So it's pretty rudimentary logic, but with a fairly simple way we can define that logic. So with tic-tac-toe, if our user is blocked here and on 6, it's going to check and say, oh, I need to look at number 2. So here's our turn. So this is where we just switch turns. So if turn equals X, we return 0. If it's equal to 0, we return X. In other words, we just have it. So it flip-flops the pieces. Here's our congratulatory piece. So if the winner does not equal tie, we print the winner blank 1. All right. So whoever is the winner, either the computer or the human. If winner equals a computer, it'll print out the snarky as I predicted. I am triumphant. Proof that computers are superior. If you won, it prints, no, 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 it cannot be. You tricked me. And then if it's a tie, which is a likely outcome, it gives us another snarky answer. So the reality is our logic then down here, once we create those functions and we write them out, and we say this function is going to do this, this, and this, we can write that main logic. So we display the instructions. We find out which pieces. So we assign computer and human to pieces. We start with an X. So that's why we flip-flop back to zeros and X's. We always start with an X in this particular game. So whoever has the beginning piece gets the X. We run the new board. We display the board, and then the game loops while there's not a winner. So in other words, while there's still a move open, it continues this loop here. So it says turn equals human, move equals human move, and it passes values in, else move equals computer move. So it just flip-flops back and forth, and it runs this program. At the end then, after this exit loop, so when the winner board is full, in other words, there's been identified a winner by the logic in our function, then it runs the winner is equal to the value that passes out a winner board, and then we congratulate, and it passes the value for the winner back in and passes that back out. So the reality is it's much easier to write this, and we could write this entire program without functions, but it gets pretty ugly. So make sure you work through and you build this by scratch, by hand, and look at these functions and understand how they work. Again, this class, there is no way to make it through this class without doing looking at and determining how do these functions work. And these functions make our life a lot easier when we start looking at a game function. So the book goes through that fairly well. It just takes a long time. So you're going to take at least a couple hours to work your way through all these. And we don't have that much time in class, obviously, to go through each individual piece. But those functions are how we're going to build our entire programs from now on. So I really do expect our programs are going to have this structure where we're going to define, if we have global variables up here, we're going to have a list of our functions. And in fact, our main program in most cases is going to be inside of a main function. To start the program, we're going to have a simple main that's going to loop back up here. And that puts that entire function, that entire program in a main. Now, why would we do that? Why would we put our entire program inside of a function? Well, the simplest answer is, in many cases, we may construct a program for tic-tac-toe. But we may have another program external to that. So we may have a program called Play Games that's got a menu item of play tic-tac-toe, play chess, play Scrabble. And so this gives us the ability then to loop into individual programs or individual pieces like that. So what we're doing is that idea of iteration. So if you went to the speaker last night, she mentioned iteration. Iteration here, we're talking about we redo these pieces of code over and over and over again. And in fact, we may use pieces of this code when we use a Scrabble game or a chess game. So in this particular case, tic-tac-toe is pretty easy to define. And almost any 5-year-old can play tic-tac-toe. We know the rules. It's pretty easy. If we look at a game like chess, chess is probably one of the more complicated games we're going to play. And the reality is chess has millions upon millions of moves. And so logic like we wrote here isn't going to work. We have to write some kind of an iterative logic where it scans through possibilities, looks ahead. This is pretty simple. Literally the logic with tic-tac-toe is go to the center and don't be stupid. And it almost always results in a tie unless somebody doesn't pay attention. Or you're playing the 5-year-old and you can beat them. Other games, we have to think about that logic a little bit. Here we can do it pretty easily. So your challenge this week, so go back into Blackboard. So your challenge this week in assignments, so A, you need to work through all the way through the chapter. So this week, we're going to recreate that Guess My Number from Chapter 3. So you have to go back, and you're going to take that Guess My Number program, so you can get it from my documents. You could download it from the website for the book. I'd recommend just going down to course documents, get that program. You're going to comment, so you're going to make all these into comments, and you're going to take all this and put it into functions. So you're going to have one main function, and all of your pieces inside of there, you're going to have to write those into functions. So you need to logically block it out. So I would do that on paper. I would think about, get the original program, look at it, and define how I'm going to block it out into functions. And so start thinking about that in terms of big picture. And that's what functions do. In a lot of cases, there's already existing functions that we use. So if I go to work for XYZ Corp or Google or whoever else, there's going to be a lot of functions in their Python libraries that they've built that we can reutilize. And it gives us that ability. So rather than redefine how do I get an input from a Google search tool, there's going to be a function called get from Google tool or something. And I can reuse those codes over and over again. And it makes my programming job easier because I get to look at big picture. I don't have to look at all the minutia details. Once I create those minutia details, they're locked away in functions. Or if I want to think about it even if I'm creating all the functions from scratch, I can define my main logic, call these functions, and then go back and go, okay, I know what this function needs to do. Now I can write that function for each individual piece. So it's a way of making a big picture. So if you want to think about it in terms of a project that you've been involved in before, so a writing project, how do you normally write a large paper? You construct an outline of I want an introduction, a body, maybe I have other content, blah, blah, blah. I write out that index of what I want. Well, you're doing the same thing here. You're writing out an index of what those functions, and then you can go back and find or use or run those functions on how we want them to work. So that's what this entire chapter really revolves around, is how do we get those functions. Now, in your program, guess my number, you're going to have to deal with the issue of global versus local variables. And I encourage you to try to find a way to use local variables for everything. Now, in our tic-tac-toe program, there's a couple that made sense. Passing the X's and O's back and forth made sense. But again, if anything much more complicated, we really want to contain those variables as much to those functions as we can. That's just good coding practice. It also allows us not to have surprises. So one of the issues we might have is a surprise. So we run our code. We have a variable named new, for example. Somebody else uses that variable. So we're writing multi-users, multi-functions in a code. They made an error in their programming. They didn't zero out a variable, and it's assigned whatever value we have. And so those little programming errors, we can prevent some from ever happening. So if we use local variables, it would not be assigned prior to that function running. And so sometimes, granted, it's best practice to always zero out your variables, but we can prevent some of those. Or if we have two functions that run simultaneously, they don't get a variable passed from one to the other that we didn't intend to. And so sometimes this can be funny, sometimes it can be very tragic in terms of weird programming code issues. So it wasn't that long ago that NASA sent up a satellite going to Mars, and there was a very, very simple programming error in that they had calculated the conversion from metric to English units, or English to metric, one of the ways, incorrectly in the programming code. Nobody noticed it until this satellite was launched. $140 million plus. It's not going to work, simply because of those little programming errors. So one of the things I'm seeing as people are turning in assignments is they write the code and it works once. Make sure you go in and do some troubleshooting and try to see if your code works with different conditions. Why does it do things? So there's some programming things we can do in terms of adding in extra print statements. So identify what's going on. If something doesn't look right, troubleshoot through, work your way through like you would in the program. So if I have my code open here, and so, let me close that. Let me go back to one that's a program. Yes, I want to kill it. Chunk. So go to our program like this and work your way through and try to say, okay, if I'm on this line, what's going to happen? I follow it back up and I work my logic. And you can even do things like, well, I don't know really what that variable is. Add in an extra print statement. Now, what I would encourage you to do, so I may print a value for Jackson. I would encourage you to make sure you put in test print. Because one of the other things I saw in several people's code was I had saw that they had went in and put test comments in or test runs, but they didn't take them back out. And so you got weird things back out because they didn't take those back out. So just spend a little time. So one of the things I want to encourage, because I noticed some of these that had these weird errors were submitted at 9:59, and my guess is they started a little late. Some of these are going to take hours, and one of the best tools you're going to have in terms of troubleshooting and trying to figure out what's going on is that ability to get up and walk away from it for a while. Because when I look at this, so if I have a very simple error, so I have a parenthesis backwards or something, well, we knew in our brain what we were trying to type or what we were trying to do. And so I look at this and my brain automatically corrects that. The same way with a Word document or anything else, my brain knows what I tried to type or what I tried to do. I get into that habit of I can't find it. So sometimes if I walk away, I get frustrated, I walk away, I think, all right, let me try to find a solution for this later and give my brain a little bit of time to churn. And sometimes your brain will be churning, you'll read a newspaper or something else to get your mind off of that, and all of a sudden it'll come to you like, hey, I bet I put a semicolon in instead of a colon. And so that's one of the things I do, for example, so used to most languages use a semicolon at the end of a lot of lines. Well, Python uses colons. And if I print a semicolon and a colon up, it's pretty easy to not see that when I scan through my code. So one of the things I do when if I'm writing something in Python and I have a weird error and something doesn't work right, I'll do an F5, I'll do a control F, and I'll go, do I have a colon anywhere? And I will search through to make sure that I don't have that. And so those kinds of very common things I know to look for in my own code because I've done it often enough that I go, crap. But sometimes being able to have that extra time. So if you're starting at Sunday at 6 p.m., you're probably not going to be successful. If you start today, that gives you many days. It gives you that ability to ask questions, to ask of other resources, to go out on Google and go, wow, why is this not working? What other functions? To go to python.org and look at libraries, to go to other resources. And we looked up, if you go back up into your discussion board, we created a resource list of other places you can go for tutorials and other things to look at. And I don't intend you to recreate the wheel. And sometimes we have to go look at what have other people done? Why is it clever? How can I get from point A to point B? And then we can combine those modules together. So again, time, if you're waiting to the last minute, it's just like any other class. If I wait to the last minute to write a 10-page paper, it's not going to be the quality that if I put into it several weeks worth of effort, and I won't find all those errors, and you'll get those comments back from your instructor about, hey, you should proofread. And so that's the biggest issue with people turning in work is they know how to do the material. They can get through it, but maybe we didn't run through it and try to test it with different combinations. We made it through once, it looks good. We didn't try to put in a 5 or a 4, an out-of-scope variable or something else to test that. And in fact, that's one of the common issues with large programs. It's hard to, in these even, it's hard to find every possible solution. Well, it's even harder when you think about a program like Windows. So when Windows 8 launched, I saw a study that said they predicted there's at least 60,000 errors that are possible that are going to arrive. And they did some math and said, we've worked through all these things. We're still going to think we're going to find this many in the first iteration. And so that's why they've always got those updates coming. So something like Windows has well over 1 million lines of code. And so how we define that. Now, somebody has to think about that big picture and write, here's my main functions, what's Word or what's Windows or what is it going to do? And then they write functions for all those different pieces and start breaking it down into smaller and smaller manageable chunks. If you went out and wrote Microsoft Office without functions, you could do it. And instead of 1 million lines of code, it might be 10 or 12 or 20 because you'd have to repeat those items so many times in there. And the other advantage to a function then, say I have an error in a function the way I wrote it, I change it one time in that function and it's changed every time it's called versus if I had it in my program 12 times, well, now I have to go back up and make sure I change it every time in there. All right, let's get out of here for today. Reminder that Thursday we do not have a live class.